Assalamu alaikum. Inshallah, we will start our revision for assessment 2. Let's start. At first, we will start with limits. We will learn how to solve limits using conjugate. Okay, what's the first step? He's asking you about the limit of x approaches to 3. As x approaches to 3 of x minus 3 over 2 minus root x plus 1. Okay, your first step is plug in 3 in this function. So it will be 3 minus 3, which is equal to 0. Over 2 plus root 3 plus 1. Sorry, this one is minus. Which is equal to 2 minus 2 equal to 0. Okay, in this case we have a square root, so we will use conjugate. Let's start. This is x minus 3 over 2 minus root x plus 1. We will multiply by the conjugate up and down. The conjugate of 2 minus root x plus 1, it will be 2 plus root x plus 1 up and down. Okay, in the next step we will keep the numerator the same. It will be x minus 3 times 2 plus root x plus 1 over, and to solve the denominator we will multiply 2 times 2 is equal to 4, negative times positive is equal to negative, and root x plus 1 times root x plus 1, it will be x plus 1. Don't forget to put your brackets, and then we will keep the numerator the same. It will be x minus 3 over 2 plus root x plus 1, and then we will distribute the negative sign, so it will be 4. Negative times x, it will be negative x. Negative times 1, it will be negative 1. Next step, we will keep the numerator the same. X minus 3 times 2 plus root x plus 1, and then we will just write negative x in the beginning of our expression, and we will add 4 minus 1, it will be positive 3. And right now you just need to compare between this binomial and the denominator. We have x minus 3, so here we have extra negative sign, so we'll take it out. We will just take negative out. So negative times what give you negative x? It's negative times x, and negative times what equal positive 3? It's negative 3. And we got the same brackets, the same expression as the numerator, so we have x minus 3 here times 2 plus root x plus 1. Okay, for this step we will just simplify. We will cancel x minus 3 with x minus 3, and you will come up with 2 plus root x plus 1 over negative 1. And right now you have eliminate your zero factor, so the last step, it will be again plug in 3 in your expression. So it will be 2 plus root 3 plus 1 over negative 1. If you calculate that, it will find it to be negative 4. Okay, next question. The same, we have limit 3 minus root 5x minus 1 over x minus 2 as x approaches to 2. So in this one, the first step is plug in 2 in your function, so it will be 3 minus root 5 multiplied by 2 minus 1 over 2 minus 2. Okay, the denominator will be 2 minus 2 is equal to 0, and the numerator will be 3 minus root 5 times 2, which is 10, minus 1, 9, root of 9 is 3. 3 minus 3 is 0. It's undetermined quantity, so you have to use one of three things: a factorization or conjugate or trig identities. In this case, you will use conjugate because you have in square root. So it's 3 minus root 5x minus 1 over x minus 2. We will multiply by the conjugate of the numerator up and down, so it will be 3 plus root 5x minus 1 over 3 plus square root of 5x minus 1. as we learned before, we will keep the denominator the same, so it will be x minus 1 times 3 plus root 5x minus 1. And the numerator, we will multiply them, so it's 3 times 3 is equal to 9, negative times positive is equal to negative. And root 5x minus 1 times root 5x minus 1, it will give you 5x minus 1. Okay, next step, keep the denominator the same, so it will be x minus 1 times 3 plus root 5x minus 1. And you will distribute the negative sign, so it will be 9, negative 5x, negative times negative 1, it will be plus 1. In the next step, we will write x minus 1 times 3 plus root 5x minus 1. And in the top part, we will keep negative 5x as the leading term in this expression, so it will be like this, negative 5x, and you will add the two numbers, 9 plus 1, so it will be positive 10. Okay, in this step you have to compare between the expression of x minus 1 and the numerator. So how to make them the same? Here in the denominator we have only x, but up there we have negative 5x, so we have a crystal coefficient which is negative 5. We'll take it out by factorizing with the highest common factor. So negative 5 times what give you negative 5x, it will be negative 5 times x. Negative 5 times what give you positive 10, it's times negative 2. Okay, we have stick here, this one's 2, 2, 2, and this one also 2. Okay, so it's negative 2. We will cancel. X minus 2 is x minus 2, so we will come up with negative 5 over 3 plus root 5 x minus 1. But when you eliminate the zero factor, you have just eliminated all of your problems, so you need to get the answer. So we'll plug in again 2 in your expression, so it will be negative 5 over 3 plus root 5 times 2 minus 1, which give you negative 5 over 6. Okay, next question. We will use trig identities. Let's recap all of the rules of trig identities that we will use in this semester. We will use sine double of the angle, sine 2x, which is equal to 2 sine x cosine x. We will use cosine double of angle. We will have 3 rules for this one. The first one is cosine squared x minus sine squared x. Second one, 2 cosine squared x minus 1. Third one, 1 minus 2 sine squared x. And you have sine squared x plus cosine squared x is equal to 1. And of course, you have your reciprocals. Secant of x is the same as 1 over cosine x. Cosecant of x is equal to 1 over sine x. Cotan x is equal to 1 over tan x. And remember that tan is equal to sine over cosine. These are the main rules that we will use in this semester. So let's see our question here. He is asking you about the limit of sine x over sine 2x as x approaches to 0. So the first step, we will just substitute with 0. So we'll get sine 0 over sine 2 times 0, which is 0. Sine 0 is equal to 0, sine 2 0, which is equal to 0. It's undetermined quantity, so we will use our trig identities because we have trig functions without any square roots or something. So we'll use trig identities. We notice that we have sine 2x in the denominator, this one. Okay, we will expand it with the rule of double of the angle, so it will be 2 sine x cosine x. The numerator will keep it the same, sine x, and then we will just simplify. Remove sine x with sine x, it will be 1 over 2 cosine x, and then plug in 0 again, it will be 1 over 2 cosine 0, which is equal to half. Remember to set up your calculator on degrees. This is very important. Okay, next one. We have cosine x minus sine x over cosine 2x, and we need to get the limit of this function as x approaches to pi over 4. Okay, at first we will substitute with pi over 4, so it will be cosine pi over 4 minus sine pi over 4 over cosine 2 times pi over 4. Okay, in this case, you have two choices. Either you switch your calculator to radians, or you will just replace pi with 180, so it will be 180 over 4. In either case, they are okay, so I prefer to use 180 over 4. After you calculating this expression, the top part will be 0, the denominator will be 0. So you need to use your trig identities so that you can simplify and eliminate the zero factor and then calculate your result. Here we notice that we have cosine 2x, but we have three rules to expand cosine 2x. We will use the difference between the squares of cosine x and sine x. So it will be like this. Limit cosine x minus sine x as x approaches to pi over 4. Okay, we will replace cosine 2x with cosine square x minus sine squared x. So it will be like this, cosine squared x minus sine squared x, and then expand your expression, factorize it by difference between two squares, so we'll keep the numerator the same, cosine x minus sine x, and we will just factorize the denominator to be cosine x, negative, positive, sine x, and we used the difference between two squares. Right now, we will cancel cosine x minus sine x from up and down. In the numerator, we will have 1. In the denominator, we have cosine x plus sine x. Again, we will plug in pi over 4, which is 180 over 4, or 45. So it will be 1 over cosine 45 plus sine 45. Use your calculator, you will find it to be root 2 over 2. Okay, next question. We need to solve this one. At first, we will plug in pi over 4, which is 45. You can replace pi over 4 with 100. Pi with 180 over 4, which is 45 degrees. So we will use calculator set it up on degrees and use 45. So it will be cosine 2 times 45 over root 2 cosine 45 minus 1. The numerator will be 0, the denominator will be 0. We will have to use our trig identity so that we can find the answer. We can use conjugate, of course, but we will start using the trig identities. This is cosine 2x. So I'll expand it, but I will use the second rule, which is 2 cosine squared x minus 1, because I noticed that in the denominator we have root 2 cosine x minus 1. So I factorize this one to be 2 cosine squared x minus 1 over root 2 cosine x minus 1. For all of this, we need the limit as x approaches to pi over 4, which is 45. In the next step, we will factorize the numerator to be difference between two squares. 2 will be root 2 times root 2. Cosine squared will be cosine x times cosine x. Negative will be negative times positive, and 1 times 1 over root 2 cosine x minus 1. Cancel you'll come up with root 2 cosine x plus 1. You will just plug in pi over 4 for x or 45. We will use 45 because we set it up our calculator to be degrees. It will be root 2 cosine 45 plus 1, which is equal to 2. Okay, continuity. Let's start. First question is asking you about removable discontinuity. Okay, where are the points or the values for x that the function is discontinuous? We have 6, we have 3. Okay, we have two values for x, which is function is discontinuous, but which of them have removable discontinuity? Removable discontinuity, it's only one point removed from a function, so it's -6, only -6. This one is called jump discontinuity because you need to jump from one point to another so that you can connect your function. Next one. Okay, right now we need to get infinite discontinuity. At first we have at x equal to -5, we have discontinuity here, discontinuous point here, which is -5, and we have it here also at the value of s, which is equal to 2. But which one of them have infinite discontinuity? It's x equal to 2. Okay, next one. Jump discontinuity. Okay, we need to get jump discontinuity. Which point of the function have jump discontinuity? At first, which points is the function is discontinuous? We have it at x equal -3, at x equal 1, and at x equal 2. Okay, at x equal -3, this is removable because it's only one point removed. At x equal 1, it's jump discontinuity. So at x equal 1, it's jump discontinuity. And also at x equal 2. This one also is jump discontinuity. So we have it here, x equal 2 and x equal next. Select the x values at which h is a removable discontinuity. Okay, we need a removable here. So at x equal to -2, this is jump. At x equal to 2, this is jump. But at x equal to 4, this is removable discontinuity. So we'll choose 4. Okay. What is the slope of the secant line that intersects the graph? We need to get the slope of the secant, so the slope of the secant is equal to y2 minus y1 over x2 minus x1. Okay, whereas at first we will start with the negative sign. We will start with the values of x. We have two values for x, 2 and 3. You can start with any one of them, it's okay. So I will start with the bigger one, and it's okay if you started with 2. And then I will get f of 3 and f of 2. Whatever this number is, get its value for the function. Okay, we will make our draft. We will get f of 3. We will plug in 3 in our function. Sorry, this is g of 3. Okay. We will plug in 3, so it will be 3 over 3 power 2 plus 1, which is equal to 3 over 10. And then we will get g of 2, plug into a new function, so it will be 2 over 2 squared plus 1, which is equal to 2 over 5. And then the last step for your numbers, g of 3, it's 3 over 10, minus g of 2, which is 2 over 5, over 3 minus 2. The answer will be -1 over 10, which is -0.1. Okay, next one. We need to get the average rate of change. Okay, it's the same. If you want to get the average rate of a change, you have to get the slope of the function connecting between the 2 points at x value is equal to 2 and 5. So it is the same rule, y2 minus y1 over x2 minus x1. We will start with x, we will use 5 and 2, and then we will get f of 5 and f of 2. Use a draft. Let's get f of 5, which is equal to 5 cubed minus 4. You can calculate it and find it out to be 11. The next one, f of 2, it will be 2 cubed minus 4, which is equal to 2. The last step is plugging in your numbers, so it will be 11 minus 2 over 3, which is equal to 9 over 3, which is equal to 3. Okay, next one, we need to compare between the derivative of the function at -1 and the derivative of the function at 2. So the derivative means the geometrical meaning of the derivative, it means the slope of the function at this point. So it's like you're drawing a slope here, a tangent line here, and a tangent line here. Okay, this one, the one at x equals to 2, looks more steeper than the ones at x equal to -1. So at x equal to 2 is bigger, so we choose A. Next one. Okay, in this case, we need to decide what is the value of the slope or the gradient, the derivative of the function at 3. We need to estimate it. So at first, we will come to the x values. At x equal to 3, we will draw our slope. Okay, it's negative. So the first one is wrong, second one is wrong, third one is wrong. If it was go down, it's negative. Goes up, it's positive. Horizontal line is 0, vertical line is undefined. Okay. But we need to estimate it. So what we will do, we will just draw a triangle like this, and we will try to estimate vertical length over horizontal length. This length I estimated to be 1. This length I estimated to be 2. It's like 1 over 2. If you draw a triangle with more accuracy, you will find the correct answer directly. So it's a fraction. It's a fraction. So and it's a negative slope. So we will use -1 over 3. It's not -3. It's a fraction. The closest answer is -1 over 3. Okay, next one. Okay, in this case, we need to estimate which one of the two derivatives is bigger. The derivative of the function at f is equal to x is equal to -4, and the derivative of the function at x equal to -1. We will draw our slopes. This is the first one. This is the second one. Okay, this one is more steeper. What's the meaning of more steeper? It's a bigger number. For example, in this case, it's approximately is equal to 1. And this one, maybe it will be 0.5, for example. But both of them are negatives. Don't forget this. It's a negative slope. This one is more steeper, yes, but it's negative. So this one is like -1, and this one's like -0.5, for example. So which one is bigger? The one at -1 is bigger. The one at x is equal to -1 is bigger, so it's letter A. Next one. Okay, we need to estimate the derivative of the function at 0. X is equal to 0. If you go from this side, you will find that the tangent line is positive, and getting less positive and less positive. And when you go down, it's negative, and goes down. And it's a continuous function. And if you notice that, you must pass through 0. You must pass through a horizontal line. So exactly at the point x is equal to 0, you will have a horizontal tangent. And what's the slope of horizontal tangent? It's a 0. Okay, let's move. Okay, this one, we need to find the equation of tangent line of the graph of g at x is equal to -6. At first, we notice this in our choices. We have the tangent formula in point slope, which is y minus y1 equals m times x minus x1. So you have the point x1 and y1, and you have the slope m. This is the point slope form. So at first, let's search for m. Let's search for the slope, and we already have it. The slope is the derivative of the function at this point at x equal to negative 6, which is 3. So m should be 3. So the number in front of the bracket, it's a 3. So this one is wrong, this one is wrong. It will be one of them, one of A or B. Let's search for the point. Okay, we have it here. G of negative 6 is equal to negative 8. We remember this. We're all the time saying g of x, g of x. So the number inside is x. We will just invert its sign. So x minus negative 6. So the number beside x should be something related to negative 6 or opposite sign of negative 6. So it will be plus 6. So we'll search for this bracket. Yeah, we have him here. So y is negative 8. So we will invert its sign. It will be y plus 8 times equal to 3 times x plus 6. So the answer will be letter A. Next one. Okay, we need to get the derivative at 5, and we have 2 points. One of them is exactly at 5, x is equal to 5, and the other one, the tangent line passes through it. So how to get the same rule? Derivative is the slope of the tangent, so we will get with y2 minus y1 over x2 minus x1. This one, x1, y1, x2, y2. Just to plug in your numbers, so it will be negative, negative at first, and then negative 1, negative 7, 1, 5. Put your numbers in the calculator, you'll find it to be 6 over negative 4. Yes, 6 over negative 4, which is negative 1.5. Negative 1.5. Next one. Okay, you need to get the equation of tangent line. At first, we'll search for the slope. It's the one with dash, h dash, so it will be 1. We will search for the brackets with the slope 1. So we have him here, C or D. This one is wrong, this one is wrong. So we will just search for the point. We have it here, h of x. So x is equal to negative 4. We will search for the ones that have negative 4 beside x. We have it here. Of course, we will invert the sign of negative 4, so it will be positive 4. The answer is letter D. Next one. We need to get the slope of the function at x is equal to 2. So it is the same tangent. The derivative is the slope of the tangent line, so it will be y2 minus y1 over x2 minus x1. This is x1, y1. This is x2, y2. Let's plug in our numbers. So it will be 6 minus 3 over 7 minus 2. It will be 3 over 5. Next. Okay, we need to get the derivative of the function at x equal to negative 1. Where is negative 1? Here is negative 1. Okay, to get the derivative, as it says, the slope of the tangent line, but which 2 points we will use them for the tangent line? Of course, we will use the points that enclose negative 1, but what is the second point? It's the closest one to negative 1. So we will use these 4 numbers, and we will use y2 minus y1 over x2 minus x1. It is a rule of our slope. Okay, just don't be confused. We will use in y1 which is g of x. So it will be 53 minus 45 over negative 1 minus 1, and it will be 8. Yes, 8 over negative 2, which is equal to negative 4. So we will choose negative 4. Next one. we need the derivative of the function at x is equal to -9, but we have a problem here. We don't have x is equal to -9. So, but we have him here, we have -9 here. So we'll take the closest 2 points to x is equal to -9, which are these ones. We will use them with the slope formula, y2 minus y1 over x2 minus x1. It will be -88 minus -85 over -8 minus -10. Okay, use your calculator, and this one will be -3. This one will be 2, so it will be -1.5. Okay, next one. The same, we need the derivative of the function at x is equal to -15, but we don't have -15, so we'll use the closest points to -15, which is -3 and -13 and -16. We will use the slope formula, which is y2 minus y1 over x2 minus x1. So it will be 89 minus 77 over -13 minus -16, and it will be 12 over 3, which is equal to 4. Next one. Okay, the differentiability, we need to know is if the function is differentiable or not differentiable at this point. Okay, if the function is continuous, we have a big chance that it's differentiable, but in some cases it won't be. So if the function is discontinuous, this point it's not differentiable. Okay, if the function have a vertical slope, we know this. A vertical line doesn't have a slope. Okay, it's an infinite. So if it have a vertical slope, it will not be differentiable. And the last thing, if we have something like this, like a tip of pencil, something like this, very sharp in your function, it won't be differentiable, because this one, for example, it's a positive slope, this one is negative slope, and we have this point, and we cannot decide if it was positive or negative slope. So we cannot say this point is differentiable. It's not differentiable. Let's look at our graph and decide which points that the function is not differentiable. We have the first point. The function is discontinuous at -3 and discontinuous at 1. So I'm sure that at -3 and at 1, it's not differentiable. What else? We have this part here. It looks very sharp for the function to get directly from a negative number to, sorry, a positive number to a negative number. So at 3, the function also is not differentiable. Next. Okay, here is saying this, we have a vertical tangent at x is equal to -1, this part. So we already know this, at x equal to -1, it's not differentiable. What else? We notice this, the function is not continuous at x is equal to -3, so it's not differentiable at x equal to -3. That's it. Next one. Okay, at first it's a discontinuous at -8, discontinuous at 2, discontinuous at 1. That's it. We have -8, -2, and 1. All of these are not differentiable. Okay, it's continuous, but it's conclude a vertical line, x is equal to -4. So at x equal to -4, it's not differentiable. Okay, we have here discontinuity, so it's not differentiable at 4. And here, do you notice this one? We have here a sharp turn here. So the function is not differentiable at -2 also. Okay, at first we have a vertical tangent at x equal to 3, so it's not differentiable at x equal to 3. We have discontinuity here. We have discontinuity here at -3, so it's not differentiable at -3. And that's it. Okay, we have only one point of discontinuity, which is 0. We have infinite discontinuity here, so it's not differentiable at 0, and nothing else. Okay, we have vertical tangent at x equal to 1, so it's not differentiable at x equal to 1, and we have discontinuity here at x equal to 5, so it's not differentiable at x equal to 5.